came up from a discussion. The first one was for the need for a robust operational and maintenance management model. The Exelon model was obviously discussed, and it had demonstrated improvements in efficiency in 1.5 years in the US, and then in the same sort of timescales, they used it at KHMP engineering, where improvements happened there as well. Next question we talked about was how do we assess the effectiveness of training? The sets of KPIs being developed to ensure that training is actually improving performance. One of the key things that we need to do there is making sure that senior executives, senior management is part of the training process. They're observing the training and participating, and also they actually have strong oversight of that training process. They're involved from cradle to grave. Key customer in a nuclear power station is actually the equipment that's there. In this particular case, we need to make sure the equipment functions as it's designed to when it's called on. You've got to be tolerant of unexpected failures, and the ownership, leadership, skills and knowledge, which goes back to the training, is making sure that the equipment is in the best condition to do what it's supposed to do when it needs to do it. We need to focus on preventative maintenance rather than reactive. In other words, we don't want it to break then fix it. We want to make sure that it's fixed before it actually breaks, so it does work as designed. The timescales were then discussed if we can implement one of these management models where the policies, the processes and procedures are all in space, and we start seeing those improvements. For an operating utility, sort of external to the US, 2.5 years with the timescales quoted. If it's a new startup from a brand new station, from somebody just coming into the nuclear field, looking at 5 to 7 years. Timelines for operator training were then talked about. Takes about 8 years. It's 2 to 3 years for the simulator construction, 2 to 3 years to train the simulator instructors, and then 2 to 3 years to train the actual SROs who are going to do the training, also going to operate the plant. The quality of training, the expectations that we set out is very, very important. Exelon's achieving pass rates of about 94% for SROs. KHMP have a different model, and they're only achieving about 14%. So deciding on what you want as your outcome is very important. So do you want 100% pass rate, or do you want, as in the case of Exelon, or the case of KHMP, do you want the knowledge to be out there with everybody else, as well as just the operators? And can you afford to have those high or low failure rates? Independence of oversight. We talked a little bit about having external experts coming in, looking at spending time in the field, and then providing feedback directly to management. That's experts that aren't directly associated with like the IEA or Impel WANA. That's people, consultants, that type of thing, coming in to look at us. How we are set up as a learning organisation to discuss. In the US, if INPO come along, we're going to say we found these things, it's taken to heart and looked on very in a positive light. If we have the IEA or WANA coming to look at some of the utilities in the rest of the world, it becomes uh-oh, here comes the IEA, they can find something wrong and beat us up. So it's how we must use those feedbacks as a means of continuous improvement. And then finally, a strong corrective action programme. So it's always better to find your own problems and fix it. It costs less, takes less heartache than having somebody else coming in from outside, such as WANA, finding your problems, and then you've got to go through the reporting of it, and it's a very, very high profile type of incident. And that was it in summary. So thank you very much.